Okay guys, so this is addition polymerisation and this won't take too long. We're basically just going to talk about three things today. First of all, what are monomers and how can we change them into polymers? Then what is a polymer and how can we change it into a monomer? And finally, how do we name polymers? So it shouldn't be too long. We'll go for a few examples as well of the main common mistake people make when changing a monomer into a polymer. So first of all, what is a monomer? Well, in addition polymerisation, there's lots of different types of polymerisation. If you're an A2 student, you'll know about condensation polymerisation with polyamides and polyesters. If you're an AS student, the only thing you need to know about for now, if you do OCR, is addition polymerisation. That's all I'm going to talk about today. And monomers are basically lots and lots of very tiny identical units. In addition polymerisation, they have to be an alkene. So an alkene is just something with a carbon-to-carbon double bond. And obviously, each of these carbons will have two extra bonds that can bond to whatever you want. And depending on what's on these extra bonds, depends on the monomer you have. And what we can do is we can use a special process. There's lots of different ways you can do it. The main way is using something called a Ziegler-Natta catalyst. And what happens is all of these monomers, they get joined together in a long line to make a polymer, etc., etc. So it goes on. And these polymers are usually thousands and thousands of monomers long. So I've only drawn 4, but in reality, they're usually thousands and thousands. So they're really, really long things. And depending on the monomer you use to make the polymer, depends on the properties your polymer has. So that's why they're so useful. If you think about in your average classroom, there must be at least 100 different plastics used there. So how do we actually do this process? How do we change a monomer into a polymer? Well, I'm just going to start with a really simple monomer. And I'm going to start with, oh, I don't know. Let's start with that. So it's got a fluorine and a hydrogen and a chlorine and a hydrogen. And what the exam will do is they'll give you the monomer and they'll ask you to change it into maybe 3 repeating units of a polymer. So that can be my question, change this into 3 repeating units of a polymer. And if you follow this method, just these 3 simple steps, you'll get it right every single time. If you just try and wing it and just try and put it together haphazardly, you'll probably get it right most of the time, but certain monomers will trip you up. They do everyone all the time. So definitely do try and memorise these 3 steps and understand how to do them. So step 1, what am I going to do? I'm going to draw my skeleton. Now the skeleton is your 2 carbons that started with a double bond. Because what we do in polymerisation is we break the double bond. So these 2 carbons here in my skeleton represent the 2 that had the double bond. So here is my skeleton. So this carbon is that carbon there, this carbon is that carbon there. And as my question said, draw 3 repeating units, what that basically means is I've got to draw 3 3 monomers worth. There is one exception to that, which I'll talk about later. Okay, so that's step 1. Step 2, I look at my different side groups. So on this first carbon, I've got a Cl and a H. On the second carbon, I've got a fluorine and a hydrogen. And I just add them on. And I do the same with my other 2 skeletons. And then step 3, all I do is I join each of these different repeating units together, these different skeletons together, just by linking them with a bond. And then at the end, we need to have kind of an empty bond. And that might seem a bit weird. You might think, well, my teacher's always told me you can never have an empty bond. And in reality, you can't. But what this is representing is the fact that we don't just have 3 monomers, you actually have thousands. So there'll be many hundreds more on either end. This just represents a section of a larger polymer chain. So it's really important to keep these on the end there. If you only had 3 monomers, so if the question said, what does exactly 3 monomers look like joined together, then at the end you'll have a hydrogen on each end. but that's a very rare question. Usually they'll just say, show 3 repeating units of a polymer, and polymers are longer than 3, so we need these empty bonds on to show that. Finally, we need to show what our repeating unit is, and our repeating unit is basically kind of self-explanatory. It's the thing that's being repeated over and over again. And we show that by putting square brackets around it. So this is my repeating unit, because look, it's getting repeated over and over again. If they ask you for this, you don't need to put square brackets around every single repeating unit, just the first one. And 99.9% of the time, that will be just your first 2 carbons, because your repeating unit will just be your monomer. There is, however, a few very rare examples when your repeating unit will not be just your first 2 carbons. And I'll just go through one of those examples now. So if this was my monomer, I'd draw my skeletons. If the question asked for 3 repeating units, I would add my H's. Well, I would add all my side groups, which is H's, and then my repeating unit. You might be tempted to put your repeating unit around the first 2 carbons, but that would be wrong. In this case, using this monomer, my repeating unit would just be that. And that's because, well, quite simply, this is what is being repeated, isn't it? This here is the same as that. So that would not be my repeating unit, this is. So if the question originally asked me for 3 repeating units, I would need to do that. If the question asked me what would 3 monomers look like together, I would have needed the extra bit. So you've got to read the question and be really careful with that. Okay? Now, you might be thinking, well, how do I know whether my repeating unit needs to go around 1 or 2? And there's a really good trick to this. If the 2 things attached to your first carbon are identical to the 2 things attached to your second carbon, then your repeating unit will only go around 1 carbon. If the 2 things attached to your second carbon are different, then this is not a repeating unit of that. So my repeating unit must go around 2 carbons. Okay? I'll just go through 2 more examples of that. So it doesn't really matter what we choose as our monomer. Let's have a Cl, an F, an OH, and a H, like that. So the question says, show 3 repeating units of a long polymer made from this monomer. So what do? In reality, what's actually happening is this double bond is swinging round. And you'll see that when I draw it out. So here's my skeleton. And the question asks for 3 repeating units. Let's double check. Are the 2 things on this carbon different to the 2 things on that carbon? Well, yes, they are. So each repeating unit will be 2 carbons long, so that's good. I'm going to need to draw that out 3 times. Add on my side chains. So I've got OH, Cl, HF, and then repeat. Just be really careful as well. Notice I've made the bond go directly to the oxygen. Not between it, certainly not to the H, because that is what's making the bond. It's the carbon bonded to the oxygen. It's not bonded in between them. So you'll be really careful about that. They will pick you up on that. I've got an F and a Cl. There we go. So that's step 2, added on my side groups. Step 3, join all of your different repeating units together. Don't forget the empty bonds on the end. Everybody always forgets them. And if the question said, show the repeating unit, well, 2 things attached to this carbon are different to that carbon, so my repeating unit will go around 2 carbons. And remember, you only need to show it once. That's the point of it. Okay, all right? And let's try one more. This is the one everybody always makes a mistake on. Always. If you follow this method, you'll get it right every time. If you don't, this is the one you'll probably mess up on. And it's because it involves more carbons than just these 2 here. So what I'm going to do is, I'm going to do this question, and I'm going to do it wrong. I'm going to make the mistake everybody always makes, and you can hopefully see from that, oh yeah, that probably is what I might have done, so you won't make it again. So here's my monomer. That's a 3. Okay? And what loads of people are tempted to do here is they say, right, so I've got my 2 carbons, and this has got a carbon on the end, and there's 2 carbons on the end there. So that's 1, and these have all got H's on. And my next one, well, it must just be the same thing again, because it's just repeating. And join them all together, stick the tails on the end. Obviously, you'd have H's, all the way up here, and H's all the way down here. And that's what people do all the time. I see it. Basically, what you're doing, and this is why it's wrong, is you're incorporating these side groups into your backbone, into your main chain. But that never, ever, 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 ever happens. The only carbons that will be in your backbone, in the main chain, in the skeleton, are the 2 carbons that started with the double bond. No other carbon in addition polymerization will ever be in the backbone. So let's see how we should have done this. So just like before, again I'm going to say the question asks for 3 repeating units. So let's check. These 2 are different to those 2, so I'll need 2 carbons per repeating unit. So my skeleton will look like this. You'll notice I put the bonds going to the side groups directly pointing up and directly pointing down. And I suppose you don't necessarily need to do that. It just makes your diagram much more easier to mark by the examiner especially. So that's my 3 skeletons. Add on the side groups. Again, notice I'm making the bond point directly at the carbon. That's actually bent a little bit. Maybe let's make sure it goes there. And notice these carbons here, which did not start with a double bond, they do not end up in your main chain, in the backbone, in this bit here. They stay as a side group. And then just repeat. And then step 3, join them all together, stick your tails on the end. If they ask you, even if they don't ask you, you wouldn't lose a mark for doing this, pop on your repeating unit. It's going to go around 2 carbons, because those 2 are different to those 2. Okay? So that's the big thing to really watch out for when you've got carbon side groups. Make sure you don't incorporate them into your backbone, into your kind of a skeleton here. They need to stay as a side chain. Follow that, and it'll make it a lot easier. So that's changing monomers into polymers. That's the hardest bit. These next 2 bits are not quite as hard. So changing a polymer into a monomer, that's dead easy. All you need to do to change a polymer into a monomer, I'll just use this as an example. Let me just rub off this repeating unit. All you need to do to change a polymer into a monomer is look at your first 2 carbons in the backbone. By backbone, I mean this string of carbons going down the middle. That's the backbone. That's what I call the backbone. Look at your first 2 carbons and forget about all the rest. So obviously you won't be able to rub it out in your exam, but maybe you could cross it out or just mentally erase it. So all the rest of these are going to disappear. Get rid of your little bonds on the end and change this into a double bond. So basically, pick your first 2 carbons and remake the double bond between them. And that's it. I've now got my polymer. My monomer. Sorry, I've got my monomer. And naming these is really difficult, naming polymers. You'll probably need to go over this like 7 or 8 times, even if you're really smart, just because it's really difficult to do so. So if I've got a monomer, let's say I've got this monomer here. So the name of this monomer would be fluoroethene. Okay, so you really need to listen up now because this is proper difficult. It requires a lot of thinking. So if this is your monomer, the polymer name will be fluoroethene. You ready? Stick it in brackets. Am I going too fast for you? And put a poly in front. Too much? No. Dead easy. Stick in brackets, whap a poly in front. And the thing which goes inside the brackets is the monomer name. So it'll usually end in, well, it should end in ene because your monomers should always be an alkene. Okay guys, so that is addition polymerisation. If you are an A2 student, within the next couple of weeks I'll be doing one on condensation polymerisation as well. So keep your eyes peeled for that.